Hello everybody, this is the video for the labs for paired t-test. So you should have finished your lab for independent t-test, so you should probably be familiar with how this will go from now on. And so paired t-test, this is just an example. So what you're going to do is you're going to go under Analyze, Compare Means, because we're comparing means for different conditions within the same people. And we're going to do a paired samples t-test. So Analyze, Compare Means, Paired Samples t-test. And this is pretty easy. So we've been talking about experimental things in class before with paired t-test, but here we're just doing things that are actually predictor variables. And so in this survey, this is a survey of students in a previous class in previous years. And one of the things that we asked them was how much they studied in high school, how much they studied last semester, how much they studied this semester in a typical week. So let's see if people change. I'm curious if people are studying more now in college this semester versus in high school. And so it's really pretty easy. So since I think people study more now versus high school, I'm going to first click. It says hours study per week this semester. I just click it. I won't double click it because it's been acting a little bit weird, but you can just click it over. See, it goes into variable 1 and it says, oh, variable 2. So for the same people, I wonder if that differs from how much they studied in high school. So here's a variable in terms of how much they studied in high school. So for every person, we're going to compare how much they studied now this semester in college versus high school during a typical week. And so let's press OK. And here's our output. I'm going to do the same thing. I'm going to snip this so it's easy to kind of manipulate and read. So here's our data. I'll expand it a bit. This might actually in some ways be a little bit easier than the independent t-test in some ways. So it's similar. I'm going to do this little clicky thing. So first it gives us descriptive information. So remember that we're looking at the same people, but we're comparing two things. So this is how much they study this semester. This is during high school. So this semester, here's the mean. 21 hours a week. And standard deviation of 15.26. In terms of high school, this sample said that they studied 17.62 hours a week with a standard deviation of 19.4. So here's our descriptives. And down here is the t-test stuff. So the t-test stuff, it's pretty easy. Here's our t. So here we have a t of 2.38, rounding up. We have our degrees of freedom here. And here's our significance test. So remember, this is two-tailed again. So we take the two-tail, 1. We have to divide it by 2 to get the one-tail. The one-tailed one. So in this one, it's 0.023. So we divide that by 2, and that should be 0.0115, I believe. So it's very late when I'm doing this, and so my mind's not working fully. So basically, there's a 1.1% chance that we're making a type 1 error. We can live with that. So remember that our probability, again, we have to divide it by 2 if it says two-tailed there. We don't have a choice in the t-test. It's always going to be two-tailed, so do a one-tail conversion, divide it by 2. And as long as that significance level is below 0.05, then we reject HO, because If it's below 0.05, we're saying that there's less than a 5% chance that we're making a type 1 error. That's good. If the significance, the sig level, is more than 0.05, then we have to say we failed to reject the HO because the probability of us making a type 1 error is greater than 5%. And then here's the 95% confidence interval. So we have a significance test here. Even if the two-tailed is, but one tail is even more significant, 0.0115. So we can simply write up a sentence. Students in this sample reported studying more this semester, parentheses, mean equals 21.00, standard deviation equals 15.26, end of parentheses, so studied more this semester, mean standard deviation, than in high school, parentheses, mean equals 17.62, comma, standard deviation equals 19.40, end of parentheses, comma, t, right here, t, parentheses, 38, so 38 degrees of freedom, t, parentheses, 38 degrees of freedom, end of parentheses, equals 2.38, comma, p is less than 0.05. We aren't doing effect size in SPSS here. So the other sentence is just simply the 95%, the 95 CI was brackets 0.50, comma, 6.27, end of brackets, period. So that's how you interpret the output in the paired t-test. So for your lab, I've run these analyses on another data set. So this data set, we're looking at the same people and how much they report sleeping during the first week of semester, midterm, spring break, the week after spring break. So there's two paired t-tests that I ran for this one. And so one is, so analyze, compare means, paired t-test. I'll drag this out here so it's easier to see. So one, we compare the first week of the semester with the midterm. And so we just ran that. And right here, we have first week of the semester, midterm. You have your means and standard deviations up here. And then you have your t-test information down here. And it's up to you to interpret those things. Then the second one that we did was analyze, compare means, pair t-test. I want to reset this. I'll drag this so it's easier to see. Comparing sleep during spring break versus sleep the week after spring break. So again, you have your descriptive stuff here and your t-test here. So hopefully this was a helpful video, and I will see you around. If you need help, there are the live sessions 4 times a week that you can ask questions about this lab if you have questions. Okay, have a good night, or a good day, or good morning, or good afternoon.